for today are pretty similar to the ones for last time. There's still a midterm next week. There's still a homework due this Friday, all that fun stuff. I want to spend a bit of time talking about the lab that you all are going to go through tomorrow because it deals with complex numbers, and in the past I've gotten some complaints that some people have never seen complex numbers. So, of course, next Wednesday, 1 week from today, is midterm number 2. 1 week from tomorrow is lab quiz number 2. It will follow, the most material it's going to cover is ifs and decisions, which are the last 2 slide sets. It's going to, and methods as well. And it will cover a little bit from the current slide set. There's not going to be very much on class creation. In particular, we're not going to expect you to be able to create classes. But if we present you with a class, we could very well present you with a class and ask you to reason about it or to answer questions about it. We're not going to expect you to write a class on test 2. We're saving that up for test 3. So if decision and methods are the main part of the test, obviously anything before that is fair game. But I mean, realistically, we're not going to ask you lots of questions about 3 plus 4 and sort of the basic Java types. That's going to sort of be incorporated into a lot of the material that we will ask questions on. As always, previous tests are on the website, and you can take a look at those when you're studying. I think I pretty much hit everything. Questions, comments, concerns? All right. So the lab this week, I know it's kind of small text. The lab this week is dealing with creating classes. And indeed, that's what the next couple labs, or the labs for pretty much the remainder of the class, are going to deal with. Some of them are going to be dealing with a concept called arrays, which we have not seen yet. But in general, we're going to talk a lot about creating classes, and that's what tomorrow's lab is going to deal with. We are going to be dealing with complex numbers. Now, complex numbers, I've spoken to people higher up in the food chain than me, and the assumption is that most of you have seen complex numbers, if not all. The assumption also is that some people may have forgotten them completely. And I know occasionally we have run into people that, for whatever reason, just never got around to them, or their math classes never got around to them. So if you have not seen complex numbers, you might want to look at the lab. It's going to be posted tonight. You might want to actually look at it. In fact, I'll probably post it when I get back to my office after lecture. You might want to look at it ahead of time. You don't have to. You can certainly chat with the TAs about complex numbers. But the point of a complex number is that there's 2 parts to it. There's a real part, or a double part, 5.3, and there's an imaginary part, 3.2i. And an imaginary part always has an I there. I is defined as the square root of -1. And prior to complex numbers, you could now take the square root of a negative number. But if you have complex numbers, suddenly you can. And you can do strange things like the square root of -4 is equal to 2i. Because if you square 2, you get 4. If you square I, you get -1. And a lot of times, complex numbers will be plotted on a graph, where one graph, so in that particular graph, the horizontal line is the actual real part of the number, and the vertical part is the imaginary part. So we say 2i, but this could really be 0 plus 2i. And then you can start multiplying them together. You can say, there we go, 1 plus 3i times 2 plus 4i. And we've seen multiplying like x plus y times 3x plus 2y, things like that, right? 1 times 2 is 3. This is a FOIL method. That's what they call it, right? Do they still call it that today? I'm dating myself here. Plus 1 times 4i plus 3i times 2 is 6i plus 12i squared. Did I screw that up? I got the idea right. That's what counts. Picky, picky, picky. I mean, really. Basically, I multiplied these, that, those, and those. Now, of course, I squared is -1, right? So this is really minus 12. And then you add them all together, which, I'm going to have trouble with that. You get minus 10 plus 10i. That's like my 2-minute review of complex numbers. If you have, how many people have seen complex numbers before? Right? I know most of the people here have seen them. We're going to be talking about them in the lab tomorrow. Come on, come back. You can do it. There we go. We're going to be talking about them in the lab tomorrow. If you are unfamiliar with them, you can either study up a bit. You can look up complex numbers on Wikipedia. You can swing by any of the office hours. You can ask your TA, et cetera, et cetera. But that's what the lab is generally going to be dealing with tomorrow. Questions, comments, concerns? Okay. So this is the last slide we did last time, correct? Yes? Okay. So if you remember, I'm going to go back a slide or two. If you remember, we were talking about creating a car class. To represent cars, maybe it's in a computer game, maybe it's in a computer simulation, but somehow, somewhere, we were trying to represent cars. And we gave cars a number of properties. We gave it a color, we gave it a fuel amount, which is some integer value, obviously not gallons, because cars can't really hold 100 gallons of fuel, x position and y position. And we could then start creating cars in two different ways. The first was with the default constructor. The default constructor means has no parameters. Car C1 equals new car. So because there are no values in between those parentheses, remember that we had actually placed two constructors inside the car class. One constructor that takes in no parameters and one constructor that takes in 4 parameters. So we can call both of them in those 2 lines, one on each line. And what Java does is it looks at the parameters that you supply, none or black 1 to 500, and it will match the constructors based on that. This is called overloading. We're going to talk a bit more about overloading and more details about it many, many slides from now. And this was the car class as we had created it. We created 4 properties of the car class. If you remember, those properties are private. And we created 2 constructors. So now, let's look at this code. This is the last slide that I did on Monday. This is a different class. This is the car simulation class. And in it, we have a main method, public static void main string bracket bracket args. And in that main method, we do a couple things. We create our car object. Then we try to print out the car's fuel. C.fuel. C is the reference that was just created, right? That creates a reference, makes a point to an object, et cetera, et cetera. Dot means follow the reference. And fuel is printing out the fuel property of that particular car object that's sitting in memory somewhere. And ideally what that should do is that should allow you to print out the fuel of the car, 1,000 in this case, because when you create a new car, it by default makes the fuel 1,000 because that's what we set it to a couple slides ago. The problem is, all right, note that this is a different class. Right now there is no main method in the car class, and I'm going to get back to that a bit later in the lecture today. So remember that fuel is a private field. We said private int fuel equals 1,000. That's actually how we, semicolon. That's how we declared it in the car class. And in particular, what private means is that any code inside the car class can do whatever it wants to fuel. Can set it, can read it, can write it, can manipulate it. But once we are outside of the car class, and notice we're in a different class here. This is a car simulation class in our car simulation.java. Once we are outside of the car class, we cannot access that private field. Private means it's private to the car class, meaning that only the car class can, even knows that that fuel exists. Any code outside the car class cannot access it. We are going to see exactly why we want private variables in a bit. Right now I want you to have a general idea of what private means. Why we actually care about all of this will become clear. The next example I go over after the car class, and this is going to start on Friday and continue into Monday, that's going to actually explain why we care about privateness. Right. In particular, Java will compile this code. It's going to say attribute fuel has private access in class car is going to be the error message. If we had declared fuel as public, public int fuel equals 1,000, then this would be fine. Public means anybody anywhere can use that particular variable. So the problem, of course, is now how do we do anything to the fuel? Because if we're outside the car class, and of course now I'm talking about code in the car simulation, we can't read it, we can't write it, we can't really find out how much fuel the car has. So I'm going to create a pair of methods called accessor methods. Or I'm going to create some methods called accessor methods, called getFuel. Public int getFuel, return fuel. So notice a couple things about it. This method is, wait for it. This method is public. That means anybody, anywhere can call this method. Once you've created a new car C, car C equals new car, I can say c.getFuel. Well, what this does is this actually is going to read the value of fuel and return that value to whoever called it. Now, this code is inside the car class, so it can read the fuel. Remember, fuel is private to car class. This code is inside the car class, so it can happily read the fuel. Java won't complain. Because this method is public, anybody, anywhere can call that particular method. And we create them for all the others. X position, Y position, color, and fuel. All of them have accessor methods. We now have 4 more methods in our car class. All of them allow us to access a specific private field of one of, let me try that again. All of them allow us to access one of the 4 private fields defined in the car class. Remember they're called accessor methods because they allow us to access or read or find out the value of something. These don't allow us to set it. Those are going to be the mutator methods. We'll see in a minute. But they just allow us to access or find out some property of the car. If someone hands you a car object, well, I mean, if you're a Java function or method and someone hands you a car object and you want to find out what color it is, you would then say, call the getColor method. You can't access the color field directly because it's private. So now we can create cars. We can find out the properties of the cars through these accessor methods, but we can't change the properties of the cars. In particular, you can't make the car move. You can't repaint the car. You can't add more fuel to the tank because so far there aren't any methods that allow us to do it. So next up, we want to figure out how to set the methods of, set the fuel of a car. And for that, we're going to create a mutator method. Remember that a mutator method allows us to mutate or change some aspect of the object. So here, this set fuel, the set fuel is going to allow us to modify the fuel of that car object. It takes in some integer parameter f, which is going to be the new fuel. It does not return a value, and it is public. So anybody can call it. It then sets the fuel of the car to whatever the parameter was. So keep in mind that anybody can call this method and pass it in really any integer value you want, 1 billion if you want to. And then what this method will do is it will modify the fuel property. This method is in the car class, so it can happily modify the fuel. And then we have them for all of the other properties as well. So I'm sure you're probably saying to yourself, why the heck are we doing this? Why not just make all the attributes public and then you won't have to deal with this? I'm going to ignore that question for about another dozen or 2 dozen slides. I have a much better example that shows exactly why, but I don't want to get into that just yet. Keep in mind that there is a really good reason why we have these get methods and these set methods. We just haven't seen it yet. Right. Okay. So these methods are together called a get-set pair, because there's a get fuel or a get something, and there's a set fuel or a set something. Generally, they're used to change or find out the value of a private variable. And as I said, I'm going to show you exactly why this is done in great detail, but in the next class example. after car, we go over some miscellaneous stuff, and then we start talking about the circle class. And in the circle class, we're going to, I'll show you exactly why. So this is our car class so far. And now it has 10 methods, 2 constructors, 4 accessors, and 4 mutators. Keep in mind that accessors and mutators, that's just so a human classification. Java sees constructors as different, but everything else is all the same as far as Java is concerned. All right. So this is our specific constructor, right? We have our fields of the car class, and we have our specific constructor there. And here I'm going to show you a slightly different version of the specific constructor. Instead of setting the fields directly, so the one on the left sets the fields directly, fuel equals F. The one on the right calls the mutator method, calls the set fuel method, and passes in F as a parameter. So both of these, when they're finished, is going to take F and set the fuel equal to it, but it does it in slightly different ways. The left side sets it directly. The right side sets it by calling the mutator method that we saw in the previous, or 2 slides ago. Again, for reasons I'm going to show you in a bit, keep in mind that this is the preferred way to do it. It is much better to call the mutator method. The quick reason is that the mutator method might do a number of other things. It could be that the mutator method does a lot of other things that are necessary every time something is set, other than just, setting the variable that we saw in the previous slide. So again, we're going to see why later, but keep in mind that setting fields, the preferable way to set fields is by the mutator method. Right. Okay. Questions, comments so far? How many people generally feel they understand the car class up to this point? Okay. I'm seeing more hands than I expected, so that's good. All righty. Goals. It's best to avoid standing directly between a competitive jerk and his goals. I want you to know that the demotivators that were going to come up today, I thought was kind of inappropriate considering we just didn't do so hot in the NCAA tournament. So I've actually rearranged that, and that one I'll show in a month or two when people are kind of over it more. Hazards. There's an island of opportunity in the middle of every difficulty. Miss that, though, and you're pretty much doomed. Individuality. Always remember that you are unique, just like everybody else. Irresponsibility. No single raindrops believe it is to blame for the flood. No, so these seem to be not quite as funny as some of the others. Not everyone can be potential. Okay. So we have 10 methods in our car class, 2 constructors and 8 methods. 4 of those methods are mutators, 4 of those are accessors. So what's left? Well, it would be nice to have a method that sets both the x and the y position at the same time. If we want to change this position, we have to call c.setx 10, c.sety 20. It would be nice to just call one method and set both of those at the same time. We need to figure out some way to use the car's fuel. As the car moves, it burns fuel. We want to paint it on the screen so we can display it. So let's do the first. Here we have our set position. Now, keep in mind the other ones were called set x position and set y position. This sets both of them at the same time. And notice what's happening here is the first parameter, it's going to call the set xpos mutator method. And with the second parameter, it's calling the set ypos mutator method. So that's really convenience. It allows us to, through one line, set both the x and the y position instead of having 2 statements. Yes?
Every time you do a different constructor or mutator, do you have to declare the variable like in x, or do you just say x?
Here you mean?
Yeah.
Whenever you are listing the parameters of a method, you have to tell Java the type. So here, this method is specifically taking in two parameters, x and y. And Java is something called a strongly typed language, meaning that you specifically have to tell Java what type it is. Is it a double? Is it a string? In this case, I'm taking in an int and an int. There are some languages that couldn't care less. Java's not one of them. Okay. Notice that this set calls the mutator methods instead of setting the fields directly. Again, we're going to see why a bit later. So now we need to figure out how to use the car's fuel. And there's many ways that we can do that. Obviously, the amount of fuel that a car uses is dependent upon many things, one of which is its fuel economy, which is dependent on how good an engine it has, how big it is. A Hummer uses slightly more fuel per mile than a Prius, like 3 times as much fuel per mile. And other things, such as if you have a heavy foot, then you're accelerating more and you're using more fuel. If you're stop and go, using a different amount of fuel, I'm going to ignore all that. Obviously, we could make this more realistic, have a miles per gallon or fuel efficiency ratio, maybe have one for city, one for highway. I'm just going to say that for every pixel the car moves, it uses 1 unit of fuel. So if I move 10 pixels over, I use 10 units of fuel. If I move 10 pixels over and or say 3 pixels over and 4 pixels up, I use 3 plus 4 or 7 units of fuel. Again, not the most realistic. Maybe I want to do the hypotenuse instead. I'm just dealing with, I'm just saying for every pixel it moves horizontally or vertically, I use a single unit of fuel. Again, this is simple. I'm not worried about the realism here. Math.abs gives us the absolute value of its parameter. So this is the set x position method. All it does is whatever parameter is passed in, it's going to update the x position. Here is my new set x position parameter. And the line in yellow is now changing the amount of fuel. In particular, I find out the current position, I find out the new position, I find out the difference of them and make sure that's positive, and I subtract that from the fuel. So there in that one line, I mean, it's one line in Java, it's 2 lines because I don't have much space on the slide. In that one line, I have managed to modify the fuel based on how far I've moved. Also notice this. Now my mutator method, set x position, is doing more than just setting the x position. It's now setting the x position and updating the fuel. This is a somewhat precursor to, or this is a sort of preview of why we always want to call them mutator methods. Because a lot of times there are other things that need to happen when we set a variable. In this case, we need to update the fuel. Set y position is going to do something similar. I'm going to update, I'm going to find out how far I've traveled in terms of number of pixels and subtract that from the fuel. So now my fuel is decremented. Obviously, I can call c.setFuel and go and fill it up with, more gas. But now every time the car moves, it burns fuel. Not in a particularly realistic way, but I'm ignoring realism. So notice that here is the method I showed you 2 slides ago for setting both positions at once. And what this does is it calls the set x position and the set y position. If I was to instead say x pos equals x and y pos equals y, if that was my set position method, I directly set the values. You'll notice that nowhere does the fuel get updated. Right? If I directly set both of my x pos and y pos attributes in the set position method, then nowhere does my fuel ever get updated because there's nothing in here that's going to update the fuel. But instead, because I am calling these mutator methods, those mutator methods will properly update the fuel based on how far I'm moving. So the last method is drawing the car. And basically we want a method that the car object will draw itself on the screen. And I'm going to call this method paint. Paint because, or I could have called it draw. for various reasons that we probably won't get into, I decided to call it paint. And the parameter there is something called graphics, a graphics object. And a graphics object, think of it like a canvas, a computerized canvas that you can draw upon. You can draw it by putting a filled rectangle there. You can draw it by putting some circles in there. It's essentially something inside, as far as Java is concerned, it's something that you can draw upon, whether it's text, lines, circles, squares, pretty colors, that sort of stuff. So g.setColor. G is the particular object that's passed in. And exactly how the graphics object works, I'm going to kind of ignore. It has 2 or 3 methods that we care about for this particular example. G.setColor to color. So what that's saying is that from that point on, anything that I decide to draw is going to be in this particular color. I can obviously change it again. In a couple slides, we'll see examples where I change it back and forth. But that's going to set the currently used color to, in this case, either blue or black or whatever the car's color is. And then I do a filled rectangle. That's what the fillRect method does. So what this is saying is, I'm going to get to these positions in a second. But this is the X position and Y position of the upper left corner of the rectangle. And this is how wide it is and how tall it is. So that's what my car is going to look like. Pretty advanced graphics, huh? In particular, that's the center of the car as far as we're considering. When we say X position, Y position in the car class, we mean the center of the car. So what I need to do is I need to go over half the width of the car. Well, my width is 100. Then I need to go up half the height of the car. The height is 200. So if I'm going over half of 100, I'm subtracting 50. If I'm going half of 200, I'm subtracting 100. So that's why we say X position minus 50, Y position minus 50, as I'm going from the center of the car up to the upper left corner. And then I say that I want it to be 100 pixels wide and 200 pixels tall. But maybe we want to easily change the size of the car. What if instead we want it to be 150 by 300? So what we're going to do is we're going to use constants for the car's height and width. So here we have a constant for the width and a constant for the height. And this now is our new method. From the current position of the car, I'm going to move over half the width. From the current Y position, I move up half the height, and then I make the car of the right size. So it makes it a bit easier to change the size, because then I can just change this, and everything changes appropriately. So this is probably not the most exciting car ever drawn in a computer program. So let's add tires. There we go. That's adding tires. I'm not so worried that you know exactly what this means. Basically, this is how wide the tires are, how high they are, and how far they are from the car. And this is basically drawing all the colors. In particular, notice that here I set the color of the car to whatever the car's color is, blue, and then I draw the car. Here, I set the color of the car to black, because as far as this program is concerned, all car tires are black. And then these 4 lines, or 4 statements, then draw the tires. And that's what our fancy car looks like. Now, again, you're saying, you know, this doesn't look anything like computer games. Well, yes, that's absolutely true. Turns out, if you actually look at the credits of computer games, most computer games today have actually more artists working on it than programmers. And what the artists are doing is they're basically creating all this really nice art. In Photoshop or some similar program, they're drawing exactly what the car looks like with shading and colors and all this other stuff. And they give it to the programmers who write stuff like this. So, yes, we could make the car a lot more realistic, but that sort of delves into the artistic side, which is sort of beyond the scope of this class. So this will do for our fancy schmancy car for this example. So the question was, how does 3D graphics work? And so there's a whole course on this. In fact, I teach it every fall, although you have to go through a couple more courses before you can do it. Very briefly, 3D graphics, you actually are, you give the computer a model of the world. There's a square here, there's a sphere here, there's a wall there, there's a person there, and it actually will do all the drawing for you. And what you need to do as developing is you need to place the various objects in the world. There's a monster here, there's a treasure chest there, and it will go and actually draw each frame for you as you move throughout it. The difficulty, of course, is you still, I mean, here we've drawn a car, but it's not the most realistic. When you're drawing a treasure chest or a monster, you also have to make that more realistic, and that's, again, in the realm of artists. In terms of, I mean, if you're really interested in 3D graphics, I'd be happy to chat. We probably should chat offline just because, I mean, I could teach a whole class on, like a whole entire course on computer graphics, and that's taught, I teach that in the fall. So let's actually chat offline for more details. But that's sort of the 10-second overview of computer graphics. So the last thing I want to talk about is what happens when the car runs out of fuel. Well, there's many things that we could decide to do. We could say, you can't move anymore. And that's probably the most realistic, right? If you run out of fuel, your car stops and you have to call AAA. We could print out a message saying, fill me up. Or I could just color the car red, which is actually what I'm going to do. It's simple. You will notice really quickly when it runs out of fuel. So it'll keep moving. It'll just be colored red. So what I'm going to do, inside the paint method, I'm going to insert this code. If the fuel is less than 0, or maybe I should have said, you know, less than or equal to 0. If the fuel is less than 0, color equals color.red. So I've now permanently changed the color of the car to red. Again, this is, I mean, I'm doing this for simplicity. Obviously, you could do stuff that's a lot more complicated. You could say if fuel is less than 100, you know, print out you're low on fuel, et cetera, et cetera. We'll just say once we run out of fuel, I'm going to make it red. So now my drawing the car method has that little segment at the very beginning. It checks to see if we are out of fuel, and it will check it each time. That's fine. If we are out of fuel, then the car is colored red. As we're going to see, it starts out as blue, and then it's colored red. Question?
Yeah. So if you will not adjust the view at all, instead you should let it keep going down into the negative control. So if
Yes.
you can do anything, it would just keep going.
Yes.
It doesn't care about the view.
The question said, I mean, he was pointing out the fact that even though we color it red, every time we move, we're still decrementing the fuel. So the fuel is just going to get into a lower and lower negative number. Obviously, we could, you know, write code that deals with that. You know, if fuel is less than 0, then don't bother updating it. But now, as you continue to move, it just the fuel gets lower, you know, lower and lower negative numbers, but the car is going to be colored red. And there's our red car. Pretty fancy, huh?
I know that intro itself can hold a lot of numbers. To say that if we didn't do anything and we just let it keep going, instead we reach the end of the maximum number negative intros that it can hold with the program crash.
The question was, if you keep letting it run, it gets smaller and smaller negative numbers. Eventually, it's going to hit the minimum integer at negative 2 billion and change. That would probably take a couple days of running it. I don't know exactly what would happen, but I mean, it would have to run for a couple days straight before it actually hit that. I mean, you're going to see it's going to take a couple seconds for it to go 1,000, and you can imagine it going 1,000,000 times that, 1 billion being 1,000,000 times 1,000, of course. I mean, we could run it for a couple days and see. Okay. So on the website is code that does all this. Now, there are 2 classes on the website. One is the car class. The car class is exactly as it was presented here in lecture. In particular, this is the old constructor that we decided not to use because we're calling the mutators in that constructor. We have the accessors. We have the mutators. We have the constants, which are dealing with the car width, height, and that sort of stuff. and we have the paint program, the paint method. And I don't know why set position isn't there, but, oh, there we go. There's set position. So that's the car class. Oh, I think I also start off fuel at 2,000 instead of 1,000. But that's the car class as was presented last lecture and this lecture. The other one is the car GUI class, and that's what I'm going to run. I'm not expecting you to actually understand anything in the car GUI. You're welcome to look it over, but there's a lot of stuff that we have not seen today, nor will we see in this course. Nested classes, J-frames, a lot of other funky stuff like that. But this is the class that when you run it, oh, come on. There we go. And there we have our car. So we can do various things, like we can make it, x++ is going to increase the x value, which is going to move it slightly to the right. You notice it's moving over to the right. And then we're going to move it to the left, and down, and up. And I got really bored trying to do that. I'm trying to think how many times am I have to click. I'm going to have to click 2,000 times. That would run out of fuel. So then a run, which is just a loop, and it just starts sort of spazzing out. I mean, moving around in random directions. And look, it ran out of fuel. All right, let me show you again because that was way cool. How do you make what? Oh, the question was, how do you make the buttons? That's something also we haven't seen. So the car GUI class deals with everything else. It creates the buttons, it creates the screen, it creates the graphic object. All the stuff that, how the car behaves is the exact car class that we've seen. Everything else here that I'm kind of waving my hands at, like the buttons and how the buttons work, that's stuff that we haven't seen. So then again, I run it, and eventually it runs out of fuel. And there we go. We know it ran out of fuel. And you can continue running this as long as you want. I think it does for like a couple thousand iterations. It's just going to sort of randomly go in various directions. And depending on how the random numbers work, it actually can move right off the screen. I don't know if it's going to get there. Yes?
Can you speed the rate at which it moves?
The question is, can you speed up? There we go. Can you speed the rate at which it moves? And you certainly can. I think what I do is I picked a number between 1 and 5 and had it move in that direction, 1 to 5 units. I could have picked a number between 1 and 50 or just set it to 100. And there we go. It's exiting off stage right. Or I guess that's stage left, isn't it? Nope. You see why I put the run button in there, because that was just getting kind of tiring. So again, you can download this. Everything in the car.java you should understand. Everything in the car GUI I'm not expecting you to. There's a lot of stuff that we have not seen. Okay. Is it really 40 minutes past the hour? Mm-hmm. My goodness, time flies. Oh, no. Oh, of the 2 people who responded. All right, let's try this again. Come on. Come on. All right. Let's try this the old-fashioned way. This was having some problems when I loaded it up. How many people would say they're either a 1 or a 2, just by show of hands? Okay. I'm seeing, so it's not everybody, but I'm seeing a good number of people. This is obviously my first, the first class that I'm actually presenting. I'm going to go through and be presenting a series of a number of classes both in this slide set and in future slide sets. So if you feel a little bit confused, don't worry about it. Go through it, and I'm certainly, please see myself or someone else during office hours. I'm not expecting you to be experts on this yet. So every year they come out with demotivators, and sometimes they're great demotivators. Sometimes they need, actually no, I think I'll show a different one. Oh, you'll like it better. Okay, right, and do that. So there are, SIGGRAPH is the big conference it's in the summer, and it's the conference for computer graphics. And in particular, they have this one thing there called the electronic theater. Electronic theaters, they take these little short films, and they show them, and they're some of the best short films that have ever been, that are created each year. 50,000 people attend this. All the big name animation studios are there. And this is one called Cubic Tragedy from a year or two ago that I thought was pretty entertaining. So this is all 3D graphics, of course. So there's a program called Maya, which deals with editing computer models like that. That's why that box is called Maxa. So I think what's one of the best parts of the conference is actually there's about an hour to an hour and a half of just shorts like this. Okay. So I want to go over a couple other things so that we can start on the circle class first thing on Friday, and I should be able to finish in the next 5 minutes. There's a number of things I am not expecting you to know yet. In particular, we've seen the keyword static. Some things have static, some things don't have static. Every method in your homework should be static. You'll notice that nothing in what we've seen so far in this slide set has been static. None of the car methods have been static. We're going to get to that in a bit. Main method is always static. Sometimes other methods are, sometimes they aren't. I said we always call the mutator methods instead of setting the fields directly. Again, I'm not expecting you to know why because we haven't talked about it. And why instance variables are supposed to be private. Again, I promise there's a very good reason. I'm just waiting for the next example to present it. So every time a new object-oriented language comes along, and Java has many, many object-oriented languages ahead of it, they decide that they're going to confuse a whole generation of students by adding lots of new terminology. So if you take a property of a class or a property of an object, like the car has 4 properties, right? X position, Y position, fuel, and color. Well, it turns out that it can be called an instance variable, a class variable, a static variable, a field, a variable, an attribute, or a property. I did not make this up. I will generally call them either variables or fields, and I'm going to try to call it variable much more often than not. Sometimes I'll talk about a property or an attribute, but that's sort of more, so I mean, you might hear me say property or attribute. I'm generally going to start using variables and fields. There is a difference between an instance variable and an instance field. I'm sorry, try that again. Between an instance variable and a class variable. Another way to say that, between a instance field and a class field, we're going to see that difference in a bit. So we consider a class that has a whole slew of methods. Public class, where to start? We have a method foo, we have a method bar, and we have a method main. And the question, of course, is where does Java start executing the program? Well, it could be that it starts executing at the first method there. But when Java was created, they said, I'm going to start executing at the very beginning of the main method. I'm going to start at the beginning of the main method and keep executing to the end of the main method, and that's it. If that main method calls other methods, so be it. Excuse me. So be it, I'll go execute those methods. But it just executes starting at the beginning of the main method and ending at the end of the main method. Notice our car class doesn't have a main method. And this is important because I guarantee you many students are going to get stuck on this. This car class does not have a main method. When I ran this thing, I ran the car GUI class, which some of the other does have a main method. But this car class does not have a main method, and if I try running this, it gives me an error. Exception in thread main, java.lang.no such method error main. What that's saying is Java could not find a main method. Maybe it didn't find it because you forgot to put the string bracket args as a parameter. Maybe it didn't find it because you didn't make it public. Or maybe it didn't find it because it just wasn't there. But if you get that sort of message, that means that that particular class does not have what Java considers a valid main method to run. And that's fine. This particular class, it's not supposed to have a main method. We don't run this class directly. We run the car GUI class, and the car GUI class calls the car class. The last thing I want to mention in the 30 seconds I have before you all are going to head out, keep in mind that a local variable, and a local variable here is something defined inside a method, is not initialized by default. You could say int x equals 5 and then creates a variable x, gives a value 5, but if you just say int x, it does not give it a value. So this is any variable declared in a method or within a block in a method. This is a pretty dumb way of doing it. Whatever, that's Java, we have to cope. Any parameters are initialized to whatever value is passed in. If you have a method that takes in a parameter, when that method is called, that value is supplied to the parameter. Instance and class variables, meaning something defined within a class, such as the fuel, the x position, the y position, and the color of the car class. Again, the difference between the instance variable and class variable I'm ignoring for now. Those are all initialized to default values. Numbers to 0, booleans to false, and yeah, you're not working anyway. Objects to null. So keep in mind that sometimes Java will initialize it, sometimes it won't. And we will start the circle class on Friday. I will see you all then.